Hi, friends, and welcome back to Curiosity Studios at the Pacific Science Center in beautiful downtown Seattle. I am so excited that you got a chance to join us today for our virtual planetarium session. This is something we've been doing all week and we've been having, or all summer, and we've been having lots and lots of fun being curious about the nighttime sky and acting like backyard astronomers. Now, last week, we invited you to start asking us a lot of questions about outer space and things that you might be able to see as a backyard astronomer. And this week, we have some answers for you. So with that in mind, I say, let's just go ahead and get started. I'm really excited that so many people are able to join us from so many different places. As a reminder to kind of help the participation going, help that community of curiosity happen. I am really excited. If go ahead and post on chat. My friend Zita is right there. She's another educator from Pacific Science Center, and she is there to help answer some questions or relay some questions that you might have to me so that we could go out and explore together. In the meantime, like Zita and I are actually kind of curious, where are you doing your backyard astronomy? Where are you exploring the nighttime sky? We've had some beautiful weather this August and really exciting things to see. So we're kind of curious, hey, where's everybody from? Last week, we had people from Bellevue and Kirkland and Seattle and Tacoma and Portland, Oregon. It was great to see all those people come join us as a part of this community of curiosity. So if you have any questions or any observations you want to share, go ahead and post it on that chat feature right over there, and Zita is right there to help you out. Okay, so I have brought up what our sky looks like today. It is Seattle, it is around this time, and as we know from our previous explorations of the planetarium, it's pretty simple. It is the daytime sky. We only have one star that we can see right now at 3:33. Hold on, I think I just noticed. Is that a cow pie? Okay, I think I just noticed something. All right, tell me on chat whether or not you think that is a cow pie. But we're not here to look at the ground. It is fun to be a geologist, but we are going to be backyard astronomers. So let's go ahead and have Keelana and Andrea from Silverdale, Washington. Can you go ahead and hit that fast forward button and bring down that dark sky? Here we go. All right, and the sun is going to set in the west as you are on a big ball that is spinning right at past sunset. You see, there is no sun. The sun is gone. It's behind the mountains in the Olympics. But there's a nice sun glow still. So there's still a lot to see, even at 8:30 or 8:15. Including to the south, you have two beautiful planets that are out. So even if you can't make it into a fully dark sky, there are some stars that still pop out because they're so bright. And as Bella might notice from Olympia, there are two beautiful planets that are still joining us all summer long towards the south. That's Jupiter and Saturn. Now, as the time goes on, these two are going to get closer and closer together. In fact, by December 21st, we are going to have a solar split. They're only going to be about that far apart from the nighttime sky. Now, in reality, they're going to be millions and millions of miles apart. But from our perspective, they're going to be really close together on December 21st. But the sky isn't dark enough for me yet, so I'm going to continue to fast forward and bring out the nighttime sky. I'm going to even turn off the atmosphere so we get a really good look at all of those stars and the Milky Way galaxy. That's your home galaxy, shooting right down almost due south at 9:30. Oh my gosh, if you go to a really dark area, a really dark region in the sky, maybe you're out in the islands or out in the peninsula, or even in Olympia, if you just travel south a little bit, there are some great dark sky areas. Maybe if you go in between Olympia and Aberdeen, some great dark skies areas where you could see really bright stars like this. Now, like I said, we had some questions from last week, and I'm very, very excited to share some of the answers to some of the questions that we had last week. And to really get that started as backyard astronomers, there's some things that we're going to need help with to map out the sky. That's right, you guessed it. They're going to be constellations. Constellations, time, and where in the sky, near the horizon or near the zenith, is how we communicate where things are in the sky. So with this in mind, one of the questions that we got last week was from Isabella. She asked whether or not our sun will ever go supernova. And for that, I thought it would be really, really kind of cool to show you the remnants of a real supernova. Supernova, what that really means is it means it means new star. And that new star is basically a huge flash of light that happens in the nighttime sky. And the reason why that flash of light happens, almost like there's a new star, is because a star has exploded. Now, to find one in our nighttime sky, it's really hard to do. You're going to have to use a telescope and use your constellation. So we're going to pull out the constellations to help us map out in the sky. A lot of my friends might recognize this one. That's right, to the First Nations up near the Arctic, this is a polar bear, where there's his nose and there's his long neck and his long back and a bushy tail, and he's got front legs. Oh, that is a polar bear from the Inuit nations, for the First Nations up in northern Canada. Let's see it. Oh, friends, the bear's head is over here. And then this is a really long tail, but I know bears don't have long tails. So what's going on here? That's a big bear from the Greek story. So it's really weird because we have these two cultures, thousands of miles apart. Didn't even know the other place even existed. Both saw a bear in the exact same spot in the sky. I find that absolutely incredible. Now, we're going to use the big bear to help us find where a supernova once appeared in the nighttime sky. We're going to use the Big Dipper, this spoon that's a part of the Big Bear. It has pointer stars, stars that point, that head into a direction, and they point to a very special star on the tip of the tail of the little bear, or the Little Dipper. This is Polaris. Polaris is a really special star, not because it's the brightest, it's only really the 42nd brightest, but what it does for us, it helps point the way north. And that's because it is directly over our North Pole, that pole that we're all spinning around. And so if you go out as backyard astronomers, this is actually a great activity you could do later on in the fall when it gets a little bit darker. Go out and track the Big Dipper. I want everybody to be looking at the Big Dipper, and at the same time, keep your eye on Polaris, that North Star up there, as I fast forward time. And this is an activity I want you to do this fall when it gets a little bit darker, a little bit earlier, and just track the Big Bear over time. You see, as you are on a big ball that is spinning, it spins and spins and spins. The Big Bear might get lower and lower in the sky. You might see Draco moving backwards, or you might see the big camel leopardus, the giraffe, moving up, or you might see Big Bear way up in the sky. All of the stars seem to appear to be circling around Polaris, that North Star. Now I'm going to rewind this on back to about 9 o'clock tonight. So you use the two pointer stars to find a North Star. What I want you to do then is to keep on going. We are going to be looking for a constellation called Cassiopeia. She is the queen of Ethiopia. So you use these two pointer stars, you go past the North Star, right past the king of Ethiopia until you see a big, well, some people call it a W, some people call it a giant M. There's a little satellite floating right by her head right now. It's going to go right through her head. Some people call it like mountains. You know what? Go ahead and share on chat what you think these pattern of stars looks like to you. Because what's important is how you remember where it is in the sky based on its shape. For example, I don't see a Queen of Ethiopia. I see some mountains. That's what I like to think about. And maybe they're actually the mountains from Ethiopia, those high regions of that country. Okay, so that helped us map out where Cassiopeia is. A really, really long time ago, there was something that blew up there. It almost looked like there was a new star, a supernova that flashed up in the sky. A guy named Tycho Brahe actually discovered it. He had a bronze nose, which was, you know, I guess that's fashionable. I wish I had a bronze nose. That would be cool. So it was basically a big star that brightened up in the sky. And what that really was, well, friends, it wasn't a star. It was a star, but it no longer is a star. You see, friends, what ended up happening is that star was so large and so big, it exploded. It exploded so vastly that we have a new view of what that star now looks like. This is Cassiopeia A. It is a gigantic, huge, amazing, gigantic cloud in the sky. And what it is basically the leftovers of a star that was it ran out of fuel. And when it ran out of fuel, it basically, all of its tiny little pieces bounced and blew up. This happened, it's about 11,000 light years away from us. And it is massive. From this side to this side, it would take light to travel from this dot right here, 10 light years to travel to this side over here. And what this is just basically leftover stuff from a star. Leftover elements like oxygen and iron and, well, gold and nitrogen and silver. It's made out of star stuff. The very elements that make up you and me. You see, when stars like this explode, they shed out all of these elements into the universe, and they eventually come back. And this are the very same ingredients that make up you and me. I just find that absolutely amazing. Now, this is a really, really colorful picture of it because scientists kind of like to play with the colors to see what the different elements are. The different colors actually reflect different elements. If you got a really, and I mean really nice telescope, it's going to look a little bit more like this in the nighttime sky. But it is still a sight to see because you could see how like the balloon popped and it really looks empty on the inside, where a very, very, very tiny, tiny, tiny object still glows. The absolute leftovers of what a star was. Now, the question was, hey, can our sun do this? And the answer is probably not. It's just a little too small. It's a middle-aged star and a middle-sized star. And while it's going to have episodes where it kind of burps and sends out some stuff, it's not going to make those big explosions like Cassiopeia A did. So what else can we observe in the nighttime sky? You know, those things could be a little distracting. And then also, let's see if we could pull up our chat feature again. Did I say gold? Absolutely, I said gold. Gold is made out of supernovas, stars that explode. That's why gold is so rare, because we think that may be the only natural way to make gold. I imagine that we must have a huge, huge fan of gold out in our audience of Community of Curiosity. All right. Oh, also around 9 o'clock, we finally have it. It is a beautiful, beautiful moon starting to rise up. Now, it's not quite a full moon, but my goodness, that is really, really close to a full moon. It is a fantastic, beautiful moon. And many of you Well, you know my favorite thing to see on the moon. As soon as you see it, you cannot unsee this. It's not the man on the moon. It comes from China and Japan. They see a rabbit on the moon. There are the ears. There's the bunny head. And the big bunny body with a bunny bushy tail right there. And he's kind of curled up, almost look like he's about to hop over something. Some people actually imagine it the other way, like there's the head and then those are the feet. And you see the bunny jump, like there's the head. And instead of a tail, those are the ears.
Hey, Michael. This is Zia. I'm going to interrupt really quick. We actually can't see the rabbit at all, but that's mostly because we can't even see the moon right now.
Zita, thank you so much for pointing that out to me. I am so sorry. I keep on flipping through screens. It's that fun technology that we do, you know? So there's that beautiful, beautiful moon up in the nighttime sky. It is still moving because time is still moving. And I've got a really zoomed up look at it. And there were the bunny ears and the bunny head and the bunny body with the bushy tail. This brings us to, it is a beautiful thing to see in the nighttime sky. It's really, really bright. So you might not be able to see all of the same types of features that we saw on the moon just last week when we could only see half of that moon. Now, this brings me up to a great question that we got last week. One of our fans, one of our communities of curiosity, Samantha, was asking us, hey, why is there no gravity on the moon? And Samantha, that is a fantastic question. The trick is, well, there is gravity on the moon. You see, Samantha, well, let's see if I could show you what I mean. Basically, there's this idea because the moon is so small, there is less gravity than here on planet Earth. But the truth of the matter is there is gravity everywhere. Everything in our solar system is attracted to everything else out in space. Just like our Earth. And our Earth, you could almost see it over to our left. There's the moon. Now the moon is attracted to the Earth and the Earth is attracted to the moon, just like I'm attracted to the Earth and the Earth is attracted to me and I'm attracted to my computer and my computer is attracted to me. Everything has gravity. But as you move farther and farther away from something, the less gravity it actually has influence. And the Earth, well, I mean, you can see it. It's a lot bigger than our moon friend over there. And so the Earth has lots more gravity, has lots more things that it's attracted to than what's on the moon. To really get an idea of, hey, there is gravity on the moon, I could really actually prove this. You see, there was this guy out in space. His name was Alan Shepard. Alan Shepard was the very first American. Whoops, did I lose my Zoom? I hope not. Okay. Alan Shepard was the very first American out in space. And he did something extremely silly. He decided that he wanted to play golf on the moon. And so that's actually kind of proof that this man right here is the very first man to ever play golf on the moon. He's the first American ever to be in space, the fifth person to ever be stepping his feet on the moon. And he does something silly. This is Alan Shepard on Apollo 14 in 1971. And as you can see, there he is. He's on the moon, but he's not floating, he's not flying away. And that little flash right there, that was him hitting a golf ball on the moon. So here's the thing, it's because there's less gravity on that moon, that golf ball had a chance to go a lot farther than here on planet Earth. But because there is gravity on the moon, it still landed. And with those bulky suits, it doesn't look actually like he hit it that far. One of the weird things is we actually think one of his golf balls that he hit, and he's about to swing again. There he goes. I can't believe it. All right, tell us on the chat feature, tell us with Zita, what sport would you play on the moon? Remember, there's still gravity out on the moon. But there's less of it, so things could go farther and things can move a lot farther. So tell us what sport you might play if you were on the moon. Okay, let's go back out into outer space. Let's go back to my favorite planets. And let's go check out some other things. I saw on the chat that somebody was interested in seeing a dwarf star. And you're right, it's really, really hard to see those remnants, those leftovers of those stars. Okay. And then we also have some other questions. But before we go to those other questions, one of the things that I want to do right now is go visit another planet. Is anybody else interested in seeing another planet? Absolutely. Go ahead and share on chat what planet that you want to see. Okay, friends, I see the Hawaiian Islands on planet Earth as we are zooming up right over it. The Earth could spin around and spin around and spin around until we are right above the Curiosity Studios at Paxi. All right, so I'm not seeing any other guesses for any other planets, and that's totally okay because we got another question about being on the moon, and that's your backyard astronomy assignment tonight. Go look for that that full moon that's out there. See if you could see that rabbit. But the other question that we have is, oh, somebody wants to play basketball so that they could dunk. Here's the thing about, oh, and then one person wants to see Saturn. So let's go ahead and visit that ringed planet really quick. So say goodbye to planet Earth. Bye, planet Earth. Whoa, that was really quick. And there is beautiful, beautiful Saturn. Saturn with its wonderful rings and it's so many moons. I think it had like 82 moons floating around. You can see those dots right there. Again, the gravity from those moons are attracted to Saturn, and there's gravity on those moons, but they act a little bit differently. The bigger moons have more gravity, and the smaller moons have less gravity. So maybe it's easier to dunk. Absolutely. Saturn is one of my favorites because of those rings. Tell me why Saturn might be one of your favorites. I absolutely love the shadows. Those rings play right on top of that planet right there. That is gorgeous. Now, there is one thing as we fly away from Saturn and all of its, just go ahead and see if you could count all of those dots, all of those moons going around Saturn. One of the reasons why people think there's no gravity on the moon is because that's a bit of a misconception. A misconception is kind of like, hey, I have an idea, but I'm not exactly sure, and my idea turns out to be wrong, and they are fantastic to explore. It is great to have misconceptions and also recognize that you have misconceptions. Part of being curious is being humble so that you can learn. Now, the misconception around no gravity on the moon is because the moon doesn't have this one other thing. Friends, the moon doesn't have any air. So you saw Alan Shepard, he was wearing that big spacesuit, and the most important thing inside the spacesuit, besides Alan Shepard, the 5th person to walk on the moon, was the air inside. And that air is really important because, well, without air, things start acting kind of funny. Oh, all right. Well, you're kind of curious, like how they act kind of funny. Do you want to do an experiment? All right, community of curiosity, let's go ahead and do that. I have with me a vacuum chamber. Now, a vacuum chamber is just like a thing that you have at home. It is a wonderful device. It is like a vacuum cleaner in that it sucks things out. But what this vacuum chamber does, it sucks out all of the air inside of here. You see, there's a whole bunch of air inside of here right now. But with this pump, I could suck out all of the air. And then weird things happen to everyday objects. So, do you want to address that misconception and actually see what happens to an object when we put inside? I am so happy we get to do this because this is among my favorite things in the entire world to do. I am going to put some shaving cream inside our vacuum chamber. Shaving cream is basically, well, I mean, look at it. It's foam. It's basically soap bubbles or soap balloons. It's basically soap like in a bubble bath. They're like bubbles or balloons where there's air trapped inside the soap. Well, if there's also air on the outside of the soap, and that gives it its shape. But if there's no more air on the outside of the soap, and there's still air pushing from the inside of the soap, what do you think is going to happen to our shaving cream? We take out all of the air from right around it. If we pretend and simulate putting this shaving cream on the moon. There's only one way to find out, friends. Here we go. 3, 2, 1. All right, you can really hear that air now being sucked out. The big pump is going, and it is... Friends, what is going on? The air inside our soap balloons, they're expanding out. There's no more air pushing down on it. Without that air pushing down, well, our shaving cream is just going to keep on growing and growing. Oh man, this is so cool. How high do you think it's not even spilling out of the cup. There's nothing to push it down to make it spill out of the cup. It's just, whoa, friends. I can even see the soap balloons. Oh, they're starting to pop. If they get popped, they're going to lose their structure. Without the air inside, it's going to kind of deflate. I'm going to stop this right here. Okay. So without air pushing down on the shaving cream, the air on the inside of the shaving cream helped it grow. You see, if you go like this, about 1/4 inch, and put it right on your head, that's about a bowling ball's worth of air on planet Earth pushing down on you right now. So what do you think is going to happen when we all add the air on back? What will happen to our shaving cream then? Well, let's make it grow just a little bit more. Then we'll add the air right back inside and all of that weight that the air has. We'll see what happens to the shaving cream then. Here we go. Oh, I love my job. Friends, do you remember that shaving cream that we had? This is what is left over. It absolutely got smashed. It's no longer foam at all. It is just this icky, well, not icky, I mean, it's still soap, but it got smashed by that air. Without that air on the inside, the outside air was able to smash it. Now, it's important to clean up, so I'm just going to rub this soap all over my face, okay? That's all right. Awesome. There was another thing that happened, that question that we had, and it was basically this. Hey, how fast can sound travel in space? And last week I answered that question, and I said sound can't travel in space. And that's because, well, there's no air in space. Just like there is no air in this vacuum chamber. So I'm going to play a little song right now. And then I'm going to put that music inside our vacuum chamber. And we're going to see if we can listen and actually hear that music actually play inside our vacuum chamber where there is no air, just like in space. Do you think it would be safe to put my cell phone inside? I don't know. There's only one way to find out. Oh, listen to that beautiful music. I hope you could all hear it. It's a little bit softer now. That's okay. Well, we're going to take out all of the air. I really like this because I can still see the music is playing on my video screen. Right now, I can't really hear it. That may more have to do with the vacuum chamber. But there's definitely no more air inside of here. Let's see if we can actually hear the music travel through the vacuum of space where there is no air. Can music travel without air to travel through? Oh, I can hear it just barely. I think it's vibrating on a little foam right there. Oh my goodness, but no, you can't actually hear anything. I don't think we actually took out any air in here. So let's try that again. Friends, sometimes you have to do experiments twice just because you didn't do it right the first time. There was something broken. And that's okay. All you have to do, this is what scientists spend a lot of their time doing. They just fix their tools. So now I'm definitely taking out the air. I don't hear anything being sucked out anymore, which means it's all going through right here. Whoop. That wasn't working because my phone was covering up the holes that we were sucking out the air from. Now I know there's no more air because I can't take off the lid anymore. And I also know, even though I could see the music play, friends, I can't hear the music play because without air to travel through, friends, there's no sound in space. You can make sound in space, it just can't travel in space. So the answer that we had last week, how fast can sound travel in space? Sound can't travel in space at all. All right, so let's go ahead and bring you back to our nighttime sky, friends. And we are going to share our screen again, right back to our original nighttime sky. There we go. Oh, am I still on this camera? Hold on, let me move over cameras. And pop, oh, yeah, no, I'm still there. Okay. Wait a second, I think we're only, well, yeah, I'll just move the camera. Sorry about that. There we go. Okay, so this is the nighttime sky that we have tonight. It is 9:30. The moon has risen higher and higher from the east. We have lots of constellations to observe.
Hey, Mike,
Mars is going to start coming up.
all we see is you again.
Again? Zita, thank you again for helping me out.
Hey, you're welcome. I mean, we love to see your face, Michael, but I know you wanted to show us some constellations.
Awesome.
And once we're back in space, Bella was hoping that we could see Uranus's rings.
Oh, could we see Uranus's rings? Bella, you're taking over the show, and I love it. I love the observation that Uranus, Jupiter, Saturn, and Neptune, they are gas giants, and they all have rings. I want you to observe what's different about Uranus's rings. And the thing about Uranus's rings is that they are very, very, very faint. They got really, really dirty, and they're just not as big as the rings around Saturn. But you might be able to notice a strange feature on Uranus based on its moons. Do you remember Saturn's moons, how they went across? Well, look at some of the moons around Uranus. They're not going this way. That's this constellation right here. That's this ring of moons. They're going around Uranus this way. That means that Uranus is tilted on its side. Something big must have knocked it over. Actually, the truth is, astronomers don't really know how this happened. I guess we're going to need some astronomers to grow up and help us solve that puzzle. Because we've only sent one robot out to Uranus before. We're going to need some more astronomers to actually, maybe build another robot and visit this really, really distant planet. Uranus is going to be out tonight too, but it's going to be really, really far away. And so you're going to definitely need a telescope for Uranus to come out and see its rings. I believe it's going to be a little bit higher in the sky. This is going to be what the nighttime sky looks like at noon. There will be Jupiter, there will be Saturn, there will be the moon, and there will be Mars. And remember, there is that little piece of what used to be a star that blew up, and the W of Cassiopeia. But as the months go on and you take your backyard astronomy even later and later in the year, as we move into the fall time, we are going to see some winter constellations come up. And one of my favorite things to actually see is Sirius the dog. Canis Major, the big dog. Sirius is a really, really bright star. It's got another constellation friend. Do you see just these two stars right here? It's a constellation just made up of two stars. It's a hot dog. It's Canis Minor, the little dog. And then you might see Orion. Orion is a big hunter, and you could really tell him out because of his belts. He has a big shoulder. There's lots of different ways to pronounce this name. Some say Betelgeuse, some say Betelgeuse, some say Bela Geese. There's lots of different ways to pronounce this name. And you might find Rigel, his knee, but what's really special is his sword. Because on his sword, well, you see that middle one right there? That one isn't a star. That one's another nebula. It's the Orion Nebula. And this time, instead of stars dying, all of those gas that were floating in space are starting to come back together. Because of gravity, they're attracted to each other. And they're going to start merging and merging together. And they're going to start spinning around and spinning around until they create a star. And then some of those other elements that are around it, while stars, hundreds of them are being formed, some of those other leftover material, like that gold and silver and nitrogen and oxygen, are going to start floating around and be attracted to each other, and they will create planets. And so from the cloud where a star once blew up and released all of those elements and made those huge giant clouds, new clouds will form and come together and make new stars, just like you can see on Orion later on this fall. And if you are ever an astronomer, a backyard astronomer, this winter. We have a great question on chat. Have aliens ever visited Earth? And that is a fantastic question, because one of the ideas about, well, how did life form on Earth is maybe they formed somewhere else. So one of the big questions is, well, is there life outside of planet Earth? And that's something I want you all to continue to explore as you move into being backyard astronomers this fall and this winter. You see, this is our last planetarium show for the year. And I really love questions like that, like, have there ever been aliens who ever visited Earth? Because they lead to other questions like, well, has there ever been life outside of planet Earth? And if yes, how special does that make that Earth? Because with all of these stars and all of these planets, actually, there are places where you could go to actually help astronomers find planets. You'll get credit for it. I have been officially accredited with discovering a planet going around another star. It's this curiosity that we absolutely enjoyed all summer long. We really appreciated this community of curiosity. It was wonderful for people like Isabella and Bethany and so many people to kind of share and bring out their questions. And Max showing off his version of the solar system, not just once, but twice. And then making crystals and making craters. It is this spirit of curiosity that we really appreciated you being able to come together and join us with these virtual planetarium sessions and help us explore and really have fun and learn a little bit more. And so, well, from Zita and from Jen and from myself, I just want to say thank you for joining us all summer as we explored our curiosity about the nighttime sky. The curiosity does not end here. It continues with each question you ask and trying to explore those answers to those questions. So that's our big wish. That's really our hope as educators. So you keep on exploring not what you already know, but what you don't know, and sharing that with a larger community. So with that, from Zita, from Jen, and everybody at Curiosity Studios at the Pacific Science Center, we want to give a big thank you to all of you for joining us and making this community of curiosity. All right, everybody. Thanks for a great summer. Stay curious.